Hello students, Mr. Madison here with yet another video key created with you in mind. As I run through these 9 problems, I'm going to be as demonstrative and as explanatory as I possibly can in hopes that you are able to catch how to do each of these types of problems. This will be your last practice. This is practice 4 on area of circles, and it will be your last one. And then the next thing you'll be doing is taking your quiz on area of circles and parts of circles. As you look at these problems, you'll see that they all appear to be somewhat unique. So there may be a little twist involved with any of them or each of them. I'll do my best to try to point those out to you and make sure that you have a clear explanation of how to do these problems. The first 2 problems you'll see are triangles. And the reason that these 2 problems involve triangles is because we are finding the area of a shape called a segment. And part of that process is to find the area of a triangle. So these 2 problems are sort of prerequisites to being able to find the area of a segment of a circle. In this first problem, notice that you are given the length of 2 sides and you're given the degree measure of the angle that is formed by those 2 sides. So this situation right here, the given information is usually described as 2 sides and the included angle. So the word included means the angle that's formed by those 2 sides coming together. And whenever you have that information, here's the formula that you should consider using to find the area. This side we'll call A, so we have a way to refer to it, and this side we'll call B. And sides A and B come together to form angle C. And here's the formula that I call your trig formula or your trigonometry formula for the area of a circle. The area is going to equal 1/2 times A times B times the sine of that angle C. So this formula for the area of a triangle is one that we will use when we find the area for segments of circles. In this particular problem, to find my answer, I'm going to put 10 in for A, 13 in for B, and 50 degrees in for C. So I would have 1/2 times 10 times 13 times the sine of 50 degrees. When you go to your calculator to do this calculation, I want you all to check and make sure that your calculator is in degree mode. All of our angles are going to be in units of degrees, so you have to be in degree mode. And to do that, you would hit your mode button, and 3rd line down, there's a choice between radian and degree. And you want to make sure that degree is highlighted. So I'm going to run this on my calculator. Now, usually what I do, to be honest, usually what I do is I take like half a 10. So in my calculator, I would just put 5. But for other problems, a lot of times instead of putting 1/2, I'll put 0.5. And that's just a little tiny thing that may save you a few moments. So I'm going to do 0.5 times 10 times 13 times, I'm hitting my sine button, 50. Now usually a parentheses opens up when you hit your sine button, and so you need to close the parenthesis. And so hit close parenthesis and then enter. Now notice that the directive here says find answers rounded to the nearest 0.01. Now that's a different directive than we're used to, because in our problems where we were finding the area of a circle or the area of a sector or the area of a ring, we always found our answer in terms of pi. But that's not the case for these problems. We're going to find our answer as a decimal rounded to the nearest 0.01. So what that means is when we get to, say, problem number 3, 4, 5, when we're finding the area of those shaded regions, we're actually going to hit our pi button when we're doing our calculation to get our answer as a decimal. This answer turns out to be 49.79. And it's going to be inches squared. This problem number 2 is very much like problem number 1, except that notice you have these little hash marks here. And of course that tells you that those sides are the same, which means this has to be an isosceles triangle. So I'm going to go ahead and write 16.2 on this side as well. And then I'm going to follow the same format for finding the area of this triangle. I'm going to use my formula, this formula right here. So I'd have the area of this triangle is going to equal 1/2 times this side, 16.2, times the other side, 16.2, times the sine of the angle created by those two sides, which would be the sine of a 112-degree angle. So I'm going to go to my calculator, and I'm going to do 0.5 times 16.2 times 16.2 times sine 112 degrees, close parenthesis, enter. And I'm coming up with 121.67. A note on this problem. This problem involves an isosceles triangle. When you have a triangle at the center of a circle, and the remaining 8 problems all involve a triangle at the center of the circle, that triangle will always be isosceles. And the reason is that the sides of the triangle are radii, and the radii are always the same within a circle. All right, let's go on to problem number 3. Problem number 3 is our first problem on this sheet that asks us to find the area of a segment. A segment is this shape right here that I'm gesturing to with my purple felt tip pen. To find the area of a segment, you are going to find the area of the sector, and you are going to subtract the area of the triangle. Now, if you, by chance, are perplexed by this relationship here, then you should go back and look at the video, the instructional video that I made for you. Either watch it or rewatch it in order to understand why the area of this segment, this is called a segment, is found by subtracting the area of the triangle from the area of the sector. So here we go on this. The area of the sector would be 112 over 360 times the area of the circle, which would be pi times 16.2 squared. This that I've written thus far is the area of the sector, minus the area of the triangle. Well, if you notice, this triangle right here is the same as the triangle in number 2. And I know that that's going to be 121.67. So I would just subtract 121.67. But I'm going to go ahead and derive how I got that once again. And I would just look up here. I'm going to use this formula. So I'm going to do 1/2 times 16.2 times 16.2 again, times the sine of that 112-degree angle. I'd like to point out, too, that this 16.2 times 16.2 right here is just 16.2 squared. So if you want to just do 16.2 squared when you're doing a calculation, you can do that as well. So I'm going to go to the calculator, and I'm going to get my answer as a decimal. So that means I'm going to have to hit my pi button here. Right here, I'm going to have to hit my pi button. So here we go. Here's what I'm putting into my calculator. I'm going to verbalize it so that nobody has any problem with the calculation part. I'm going to do 112, and I'm going to go ahead and do divided by 360. And I'm going to hit enter. Now what I just did, I took care of that fraction. I don't have to worry about it. I already took care of that 360 in the denominator there. So I did 112 divided by 360, and I hit enter. Then I'm just going to go times, I'm going to hit my pi button, pi, times 16.2. I'm going to hit my x squared button, squared. Then I'm going to do minus 0.5 times, then I'm going to do 16.2 squared again, then times the sine of 112, close the parenthesis, enter. And I'm coming up with 134.84. And you know what? That's such a long expression that maybe I'll do it again just to make sure that I didn't hit the wrong button. So I'm just going to run through it again with you. I'm going to do 112 divided by 360 and hit enter. I want to take care of that fraction first. Then I'm going to go times pi and times 16.2 squared minus 0.5 times 16.2 squared times the sine of 112 degrees, close parenthesis, enter, and I'm getting the same answer. So I did it right the first time. All right, let's go on to problem number 4. The area of the shaded region here is going to be equal to the area of the sector minus the area of the triangle. The area of the sector, it's a 72-degree sector, so I'm going to have 72 over 360 times the area of the circle, which would be pi times 15 squared. That's the area of the sector. Then I need to subtract the area of the triangle. So I'm going to do 1/2 times one side times the other side. But remember that if this side is 15, this side is 15. So I'm going to do 1/2 times 15 times 15 times the sine of 72 degrees. Time to do my calculation. I'm going to do 72 divided by 360 and hit enter to take care of that fraction. Times pi times 15 squared minus 0.5 for my half times 15 squared times the sine of 72 degrees, close parenthesis, enter. And I'm getting 34.38. All right. Problem number 5, we have another segment, and it's a 90-degree segment. So the area of the shaded region is going to be the area of the sector. And from that, I will subtract the area of the triangle. So here we go. The area of the sector is going to be 90 over 360 times the area of the circle, which would be pi times 8.5 squared. That's the sector. Minus the area of the triangle, which would be 1/2 times 8.5 times 8.5 times the sine of 90 degrees. Time to go to the calculator. 90 divided by 360, enter. Then I'm going to go times pi times 8.5 squared minus 0.5 times 8.5 squared times the sine of 90, close parenthesis, enter. And I'm getting 20.62. In problem number 6, there's a little twist. We have two shaded areas, and each area is a segment. In this type of a problem, you need to treat this as really two problems. You're going to find the area of one segment, you're going to find the area of the second segment, and then you're going to add them together. That's how you do this type of problem. So the area of the shaded region here is going to be the area of the larger segment added to the area of the smaller segment. So let's find the area of the bigger segment first. The area of a segment is the area of a sector minus the area of the triangle. So that's a 70-degree sector. So it's going to be 70 divided by 360 times the area of the circle, which would be pi times 9 squared. That's the sector. I need to subtract this triangle. So it's going to be 1/2 times 9 times 9 times the sine of 70 degrees. I'm going to go ahead and do that calculation. So I'm going to do 70 divided by 360, enter, times pi times 9 squared minus 0.5 times 9 squared times sine 70 degrees, enter, and I'm getting 11.42. That's the area of this bigger segment. Now I'm going to find the area of the smaller segment. The area of any segment is the area of the sector minus the area of the triangle. The area of the sector here would be 40 over 360 times the area of the circle, which would be pi times 9 squared. I need to subtract the area of this triangle. So I'm going to use my formula, my trig formula for the area of a triangle, and I'm going to have 1/2 times 9 times 9 times the sine of 40 degrees. I'm going to run this calculation. So I'm going to do 40 divided by 360, enter, times pi times 9 squared minus 0.5 times 9 squared times the sine of 40 degrees, and I'm getting 2.24. We said that the area of the shaded region would equal the area of the big segment added to the area of the small segment. So the area of the big segment was 11.42. The area of the small segment was 2.24. So when I do that, I got 11.42 plus 2.24, and I'm coming up with 13.66. Okay, let's look at problem number 7, where we again have two shaded regions. Each one of those is a segment. The smaller one is a 96-degree segment in a circle that has a radius of 15. The bigger shaded region is a 96-degree segment in a circle that has a radius of 33. So the radius of the big circle would be the 15 added to the 18. All right, we got a lot of work to do here. We'll call the small segment A sub 1. We'll call the big segment A sub 2. And our game plan is to find A sub 1, then find A sub 2, and then add them together to get our answer. So here we go. A sub 1 is going to equal the area of the sector, which would be 96 over 360, times the area of the circle, which would be pi times 15 squared. Then I need to subtract the area of this triangle right here, which would be 1/2 times 15 times 15 times the sine of 96 degrees. So I'm going to do 96 divided by 360 and hit enter to take care of that fraction. Then I'm going to go times pi times 15 squared minus 0.5 times 15 squared times the sine of 96 degrees, close parenthesis, enter. And I'm getting 76.61. Now I'm going to find the area of this big segment, keeping in mind that the radius of that big circle is 33. So I need to find the area of the sector. So that would be 96 over 360 times the area of the big circle, which would be pi times 33 squared. Then I need to subtract the area of this triangle. So it's going to be 1/2 times 33 times 33 times the sine of 96 degrees. So I'm going to do my calculation to get A sub 2. 96 divided by 360, enter, times pi times 33 squared minus 0.5 times 33 squared times the sine of 96 degrees, close parenthesis, enter. And I'm getting 370.80. My answer for what's the total area that's shaded here is going to be 76.61, the area of the small segment, added to 370.80, which is the area of the big segment. So I'm going to do that right now, plus 76.61, and I'm coming up with 447.41. All right, problem number 8. Problem number 8 has a little twist to it. Again, we have two shaded areas. One of them we'll call A sub 1. This is a sector, and what you need to realize is that if this is 60 degrees, then this angle right next door has to be 120. These two angles are supplementary adjacent. They form a linear pair. So this is a 120-degree sector in a circle with a radius of 22 inches. A sub 2 is a segment. And this angle here would have to be 60 because it's vertical to this 60. So this is a 60-degree segment in a circle with a radius of 22 inches. Game plan is to find the area of this sector that we're calling A sub 1, then find the area of this segment that we're calling A sub 2, and then at at the end, we'll add those two together to get our total area. Let's find A sub 1. A sub 1 is a sector, so it's going to be 120 divided by 360 times the area of the whole circle, which would be times pi times the radius of 22 squared. So I'm going to go to my calculator, and I'm doing 120 times pi times 22 squared, and I'm dividing all that by 360, and I'm coming up with 506.84. The second area here is a segment. So that's going to require us to find the area of this 60-degree sector and then subtract the triangle. So the 60-degree sector would be 60 over 360 times the area of the circle, which would be pi times 22 squared. And then from that, I need to subtract the area of this triangle. So I'm going to use my trig formula for the area of a triangle. So I'm going to have 1/2 times 22 times 22 times the sine of 60 degrees. So I'm going to do 60 divided by 360 in my calculator and hit enter, then times pi, then times 22 squared minus 0.5 times 22 squared times the sine of 60 degrees. And I'm coming up with 43.84. Now remember the game plan here. To find the total shaded area, we are going to add A sub 1 and A sub 2. So this was A sub 1, which was this sector, and this was A sub 2. So I'm just going to add those two values together to get my final answer. And I'm coming up with 550.68. Okay, problem number 9 is unique. Analyze it a little bit. We have a circle with the radius of 13 inches. Radius is 13 inches. And it seems like the entire circle is shaded except for that triangle. So my game plan here for finding the area of the shaded region is very simply finding the area of the circle and subtracting the area of the triangle. That's all I'm going to do, because everything's shaded except the triangle. So the area of the circle would be pi times the radius squared, 13 squared. And for the area of the triangle, I'll use my trigonometry formula for the area of a triangle, and I'd have 1/2 times 13 times 13 times the sine of 144 degrees. So first thing I'm going to do on my calculator is I'm going to hit pi, my pi button, times 13 squared, then minus 0.5 times 13 squared times the sine of 144. Enter. And I'm coming up with 481.26. So there you have it, folks. These problems are different than problems you've done before. You need to understand the concept. You need to understand that to find the area of a segment, you have to find the area of a sector and subtract the area of a triangle. To find the area of the triangle, use your trigonometry formula that I explained to you in the instructional video. So I also want to say that for these answers, for these types of problems, you're finding your answer to the nearest 0.01. So you're going to hit the pi button a lot when you're finding your answer on these problems. That's different than the other problems where you were asked to find your answer in terms of pi. So just to emphasize that point to you, sometimes you are asked to find your answer in terms of pi, and sometimes you are asked to find your answer as a decimal, rounded to the nearest hundredth. Be certain that when you take your quiz, you pay attention to what your answer has to look like. Make sure you read the instructions pertaining to what your answer has to look like. Okay, I hope this has been helpful to you. I'm doing my best to make it clear to you. If you do your best, meet me halfway, we'll have success. So very, very good. Thank you for your attention, and I sincerely mean that. You all have a great day.